Hello students. Today we are going to start our uh, last topic of introductory quantum mechanics. Okay, fourth unit. It is fourth unit of introductory quantum mechanics and the topic name is WKB method. WKB method. Okay students. So here what is the meaning of WKB method? I am writing the definition here. Okay, it's a very important topic students, so listen carefully. WKB, it is one approximation method. So WKB approximation method is a technique for obtaining approximate solutions to time independent Schrödinger equation okay in one dimensional and specifically for slowly varying potentials. Okay students, so actually what is that means that WKB approximation method is a technique for obtaining approximate solution to time independent Schrödinger wave equation and in one dimensional and specifically for slowly varying potentials. Okay, so it work on number 1 point, that potential means V of x is for first time independent, then number 2 it is for one dimensional, and number 3 V of x is for slowly varying. What is the meaning of that slowly varying? I am telling you, slowly varying potentials. Okay students, so this is one approximation method by which we can get Schrödinger time independent wave equation in one dimensional and for slowly varying potentials. Okay, it is also like variational method, no, it that is also the one approximation method. So all these method we use for getting the properties of any tiny particle or electron or any tiny particle uh, which is in motion. Okay students, so it is applicable classically allowed. One more point which is very important, WKB, you can also write WKB method is applicable for, what is the meaning of all these terms, I will tell you just for once you write. WKB method is applicable for classically allowed region and classically forbidden region, but not on turning point. Okay, now what is the meaning of that classically allowed and classically forbidden? I will tell you. First, we will see that what is the meaning of slowly varying potential. Okay, so see here, suppose this is one wave. Okay, and if we take one point distance which is x here, this is x, and this is dx. Okay, so now what is the change in this wavelength? It is one constant now. It is very slowly varying, very slowly. Okay, so this change is almost constant. Okay, so here x is equal to what? X plus dx. The change is x plus dx. So in this, what is the Vx here? Vx is constant. Okay, na? So there is not much change, so we can say almost constant. So okay, na? Almost constant, and it depend upon the lambda. When lambda is very small, then it is very small. Okay, so we can write here lambda when lambda is very small. Okay, I hope you are getting me. You are understanding me, students. Okay, so what is the meaning of or how much the value of that lambda? How much it is small? It is nearly equal to 10 to the power minus 34 meter. Minus 34 means very small. Okay, we cannot just measure that lambda. That much small it is. Okay, now what is the meaning of that classically allowed here? Classically allowed WKB method applicable for classically allowed region and classically forbidden region. Okay, so for this classically allowed and classically forbidden, so suppose here we have one diagram. This is Vx potential and this is our E energy. Okay, students, now suppose this is our wave. Okay, now see here, students, this point is x1, this point is x2. Okay, so our kinetic energy is equal to that potential on this point. Okay, now below this point means after this point, this is our potential. This is our potential which is less than E. Okay, this is E, no. So this potential is less than E. So our Vx is less than V of x is less than E. Okay, and these points here what happened? This V of x is greater than E. This is E and this is upside. So that V of x is greater than E here, and that V of x is greater than E on this region. Okay, students, now when potential is less than E, so what is the kinetic energy? kinetic energy is equal to total energy minus potential energy. Okay na? What is the meaning of total energy? E is equal to Ke plus V, no? Kinetic energy plus potential energy, total energy is equal to. So now kinetic energy is equal to what? E minus V. So here kinetic energy is equal to E minus V. Okay. So in this region where kinetic energy is equal to E minus V is called classically allowed region. Classically only one L. Classically allowed. Okay students, and the region where, so if this is E minus V, no, so Vx is smaller than E, so this quantity is positive, so we can see that where kinetic energy is positive, then also this region is called classically allowed region. Okay students, now the region where kinetic energy is negative means Vx is greater than E. Vx is greater than E. So it is called classically forbidden region. Classically forbidden. Okay? Means Ke is equal to Vx is greater than E. Okay na? Vx is greater than E here. So this region where Vx is greater than E, so kinetic energy is negative at that time. So this region is called classically. This is also classically forbidden region. This. Classically forbidden. Okay students, now what is the meaning of that turning point? Okay, here this method is applicable for classically allowed region and classically forbidden region, but it is not applicable on turning point. On turning point means this point where it is turn, the point where Vx is equal to E. On this point also Vx is equal to E. Okay, means potential energy is equal to total energy. So at this point kinetic energy is 0. Kinetic energy is equal to what? E minus V. When E and V are equal, at that time what is the kinetic energy? It is 0. Okay, so these points are called turning points. Turning points. These 2 points. Okay students, so this method is not applicable on these points. This method is applicable on this region and classically forbidden region. Classically allowed and classically forbidden. Okay, I hope you are getting me students. Are you understanding? Okay, so now principle of the method. Principle of the method. Here one derivation students, so please listen carefully. Okay, so what we do, this WKB method consists of introducing an expansion of the power of H cross. Okay, expansion of the power of H cross. So for this what we will do, that we will take that dou square psi of Schrodinger wave equation. Okay, Schrodinger wave equation we will take and we will solve this, plus 2m by h cross square E minus v of x psi is equal to 0. This is equation 1. It is Schrodinger wave equation, students. Okay students, now this is equation 1, no? So solution of this equation is psi is equal to c into e power I phi of x divided by h cross. This is the solution of this equation. It is equation 2. Okay, where c is one constant, okay, and phi is function of a function of x, so undetermined function we can see. Okay, we can say. So we have, now what we will do, we take that psi value and differentiate it 2 times, because we want that dou 2 psi of dou x square value. Okay, and put the psi value, these two value in equation 1, and then what we will see. Okay, so differentiate it, dou psi by dou x is equal to c into e power I phi of x h cross. Now differentiate this, so I by h cross as it is dou phi by dou x. Okay, now dou square psi by dou x square. So it is one function is this, one is this, so uv formula we will put in this. Okay, so first c I by h cross outside, then differentiate first this, so e power I phi of x by h cross into same I by h cross into dou phi by dou x into this as it is dou phi by dou x as it is, plus now this term as it is, so c I by h cross into e power I phi of x by h cross into this differentiation of, so dou square phi of dou x square. Okay students, now arrange this in proper manner. So what we will get, it is I and I square, so I square is -1, so minus c by h cross square e power I phi of x by h cross as it is. Now these two, so dou phi by dou x whole square plus, okay, c into I by h cross as it is, this term is as it is, no change, I phi of x by h cross into dou 2 phi by dou x square. Okay students, now what we will do, see here, dou phi by dou x is equal to phi prime, and dou square phi by dou x square is equal to phi double prime. Okay, so put in this equation here, dou square psi by dou x square is equal to what, minus c by h cross square e power I phi of x by h cross, dou phi by dou x square is equal to phi prime, so phi prime square plus c into I by h cross e power I phi of x by h cross phi double prime. Okay, now put this del square psi by del x square value and psi value in equation 1. Okay, so what we will get, we will get, first value is this, no, so minus c by h cross square e power I phi of x by h cross phi prime square plus c I by h cross e power I phi of x by h cross phi double prime. Okay, plus 2m by h cross square e minus v of x into psi, no, psi value is c into e power I phi of x by h cross is equal to 0. Okay, now what we are doing here, we are doing something here, or we just say equation 4. This is equation 4. Okay. Now what we are doing, okay, so from this c by h cross square, here c by h cross here, so we just add one h cross, okay, one h cross square, and c is also there, so c by h cross square we are taking common, and e power I phi of x by h cross also here, here and here also, so we are taking common here. Okay, so now inside we are not taking minus common here. Okay, so minus inside, so minus phi prime square plus 1 h cross we have to take, okay, we have to add there, so I h cross into phi double prime plus 2m h cross square common, so 2m e minus v of x is equal to 0. Okay, so this is also 0, this term is also go this side and 0. So first we will put that positive term, so I h cross phi double prime minus phi prime square plus 2m into e minus v of x is equal to 0. This is equation 5. Okay students, now what we will do to get an approximate solution of equation 5. Okay, we apply WKB method, so we apply WKB method, and hence what we will do, expand phi of x, okay, phi of x in powers of h cross. Okay students, so in starting I will tell you now, so what we will do in the principle, that we will expand of the power of h cross, so here we are doing that. Okay, so phi of x we are expanding that phi of x, so no need to write that of x. Okay, so we can write, okay, so just first I am writing, then after that we will remove that. Phi naught x plus h cross phi 1 x plus h cross square by factorial 2 phi 2 of x plus and so on. Now I am removing that x, means no need to write that much. Okay, so phi prime of x is equal to phi naught prime. Prime means differentiation. Okay, we are differentiate this, so phi naught prime plus h cross phi 1 prime plus h cross square by factorial 2 means what, 2 into 1, so we can write 2 here, phi 2 prime plus and so on. Okay, now one more time differentiated, phi double prime is equal to phi naught double prime plus h cross phi 1 double prime plus h cross square by 2 phi 2 double prime plus and so on. Now students, phi double prime value is this, phi not phi prime value is this. Okay, so put in this equation 5, we will put these two values, so what we get, I h cross as it is, so I h cross, now put the value of this phi naught double prime plus h cross phi 1 double prime plus h cross square by 2 phi 2 double prime plus and so on. Okay, so in the power of h cross, no, so only we will take just power h cross square, up to h cross square only. Okay, so when we will solve, then at the time we will take. Okay, so This is our phi double prime value. Now minus phi 1, phi prime square. So phi prime value is this, phi naught prime plus h cross phi 1 prime plus h cross square by 2 phi 2 prime plus and so on square. Okay, now plus 2m. So plus 2m, then e minus v of x as it is equal to 0. Okay students, up to here understand? Okay, so now yes, we have to solve this because the square is this, no? So after solving this square, we will put our value in this equation. Okay students, so first we will solve that square. How we will solve? Up to only h cross square we have to solve. Okay, so first take this phi naught prime plus h cross phi 1 prime plus h cross square by 2 phi 2 prime. Okay, plus and so on into same here phi naught prime plus h cross phi 1 prime plus h cross square by 2 phi 2 prime plus and so on. Solve this. Phi naught into phi naught prime square. Okay, phi naught prime into phi naught prime square plus phi naught prime into this. So h cross phi naught prime phi 1 prime plus phi naught prime into h cross square by 2 phi naught prime phi 2 prime plus now this one. So h cross phi naught prime phi 1 prime, then this into this. So h cross square h cross into h cross square phi 1 prime into phi 1 prime square plus h cross into h cross square h cross cube by 2 into phi 1 prime phi 2 prime plus now this term. Actually this term we have to neglect because we are solving only up to h cross square power. Okay na? So this term no need to take, but just we are solving, that's why I am writing here. Okay, now third term h cross square by 2 phi 2 prime into phi naught prime. So plus h cross square by 2 phi naught prime into phi 2 prime plus h cross square into h cross, so h cross cube. So just neglect all these terms because up to h cross square we are taking here. Okay, now solve this. Phi naught prime square h cross phi naught prime phi 1 prime h cross phi naught prime phi 1 prime. So plus 2 h cross phi naught prime phi 1 prime. Okay, now this term h cross square by 2 phi naught prime phi 2 prime h cross square by 2 phi naught prime phi 2 prime. So plus 2 h cross square by 2, so 2 cancel, h cross square phi naught prime phi 2 prime. Okay, so now this term plus h cross square phi 1 prime square, this is h cube, no? So no need to take. So this is, so this value this is after solving the square. Okay, so this value put at the place of that square. Okay, so put here I h cross phi naught double prime plus h cross phi 1 double prime plus h cross square by 2 phi 2 double prime plus and so on minus. Okay, so minus, put that value, this value. square value is this, no? So minus phi naught prime square. Now put minus all these. I'm opening that bracket. So minus 2 h cross phi naught prime phi 1 prime minus h cross square phi naught prime phi 2 prime minus h cross square phi 1 prime square plus 2m e minus v of x is equal to 0. Okay students, I hope you are getting me. It's very easy derivation students. Just practice 2-3 times. When you practice it, it will become very easy for you. Okay. Yes. So so what we are doing here, collecting coefficients of various power of h cross up to h cross square only. Okay students, so collecting first h cross power 0. Okay, so here not h cross is not there and h cross is not there. So first h cross power 0, so we are writing 2m e minus v of x minus phi naught prime square. Okay, now plus, now h cross power single power. So here I h cross phi naught double prime, here also only h cross power. So I h cross phi naught double prime minus 2 h cross phi naught prime phi 1 prime. Okay, we can take common that h cross also. Okay, so in next term we will take common. Okay, now h cross square power. So plus I h cross square phi 1 double prime, here minus h cross square phi naught prime phi 2 prime. Okay, and minus this also h cross square phi 1 prime square. Okay student, then this is h cross into h cross square h cross cube, so we are taking up to h cross square, so no need to take this term. Okay students, now 2m e minus v of x as it is minus phi naught prime square as it is plus, here what we are doing, we are taking that h cross common here, so inside I phi naught double prime minus 2 phi naught prime phi 1 prime plus, here h cross square common, so inside I phi 1 double prime minus phi naught prime phi 2 prime minus phi 1 prime square is equal to 0. In this also is equal to 0 students, I forgot to write. Okay, is equal to 0. Now this term also we will put is equal to 0, this term also and this also. Okay, so here what we are doing, that 2m e minus v of x minus phi naught prime square is equal to 0. Okay, next I phi naught double prime minus 2 phi naught prime phi 1 prime is equal to 0. Then third term is I phi 1 double prime minus phi 2 prime, sorry, phi naught prime phi 2 prime minus phi 1 prime square is equal to 0. Okay, these three terms we are putting separate is equal to 0. Okay, so this is equation A, this is B and this is C, and total equation 7. Okay, now 6 is where 6, suppose this is equation 6. Okay, so these are three equations we have. Now from equation 7a, we will get the value of phi naught. So phi naught prime is equal to, put this term this side and remove that square, so it will become plus and minus root of 2m into e minus v of x. Okay, now when we integrate it, that prime will become, okay, integrate it, so it will become phi naught, and this is plus and minus integration of x naught to x root of 2m e minus v of x dx. Okay, now equation 7b, from here phi naught, phi 1, okay, phi naught value we get, now phi 1 value, then phi 2 value. So phi 1 prime is equal to, what we will get, I phi naught double prime divided by 2 phi naught prime. Okay, now this will become that side, these two here from this, okay, this side, and that 2 denominator 2 phi 1, 2 phi naught prime. Okay, so after integrating, phi 1 is equal to, it is integration of I phi naught double prime divided by 2 phi naught prime dx, and this is equal to I by 2 constant, and it is log phi naught prime plus c1. Okay students, similarly equation 7c. So equation 7c is phi 2 is equal to 1 by 2, okay, 1 by 2 m into dou v by dou x divided by, this equation you have to remember directly because it's very lengthy to solve this. Okay, so remember directly this equation, 2m e minus v power 3 by 2 minus 1 by 4 integration of x naught to x1 m square dou v by dou x divided by 2m e minus v of x is power 5 by 2 into dx. Okay students, so these three values, phi 1 value, phi naught value, phi 1 value and phi 2 value we got here. Okay, so these value we have to put in equation, from equation 5. Okay, where is our equation 5? Where is our equation 5? This is our equation 5. Phi double prime value we have, phi prime value we have. Okay now, so now WKB approximation will, I am writing here, the WKB approximation will be suitable in case where V is a sufficiently smooth, and we know that slowly varying. Slowly varying, okay, slowly varying function. So we know that it is slowly varying function for position. Okay, so thus approximately WKB solution of equation 5, the solution of equation 5, I just told you now what is our equation 5. So the solution of equation 5 is phi is equal to phi naught x plus half I h cross log y naught prime in mod. Okay students, so this is equation 8. This is the solution of equation 5 students, don't be confused. Okay, where is your equation 5? This is your equation 5, no? So this is the solution of equation 5. So what we will do, we take that phi value and our, what is our that equation 2, the solution of equation 1 is equation 2, no, here. So in this equation we will put our equation 5 solution. Okay, and we get one equation. What is that equation students? It is psi approximate. Okay, what we are doing here, we are putting that that phi x value, this phi value from here, and we are putting in equation in equation 2. Okay, putting in, see here, putting in equation 2. Okay, then after putting, what we will get, c into 2m into mod e minus v of x whole power minus 1 by 4 into exponential of plus and minus I by h cross into integration of x naught to x root of 2m into e minus v of x dx. Okay students, so when we put our this value phi value in equation 2, which is the solution of equation 1, we will get that value, this value. Okay, so where c is our arbitrary constant. Now what we will do, this is our equation 9, this is our equation 9. Okay students, so equation 9 contain two solutions. Equation 9 contains two solution. Why? Because plus is here and minus is also here, plus and minus. Okay, so it contain two solutions. So write here psi approximate is equal to c 2m e minus v of x power minus 1 by 4 as it is, no change in this. Okay, now only change in this. So here into a exponential of I by h cross integration of x naught to x root of 2m into e minus v of x dx. Okay, plus b exponential of minus I by h cross into integration of x naught to x root of 2m into e minus v of x dx. Okay students, so two solution, first is plus and second one is minus. Okay, now the alternative form of this equation, actually this is our WKB approximation, it is equation 10. Okay, so now one more alternative form if we write, because it is a exponential something and b exponential something, so this is one formula of cos theta, no? So the alternative form of this equation. This equation alternative form is psi approximate is equal to, this term is as it is, no change, c into 2m into e minus v of x power minus 1 by 4. Okay, no change in this, but this is the form of cos this whole value, this is 1 theta. Okay, so cos I by h cross into root of integration of x naught to x 2m e minus v of x dx, this is 1 theta plus theta. Okay students, so it is cos x plus theta, something that formula is there, no, that formula we will put in this. So this is our equation 11. So students, these two equations called WKB psi functions. Okay, WKB approximation method complete here, and these two equations means equation 10 and equation 11. Okay, is these two equations are called WKB psi functions. Okay students, so I hope you are getting me understand, all of you. Yes, okay, so thank you very much.